Hi friends, today we are going to talk about partial derivatives. So when come to the partial derivatives place, the partial derivative means it contains more than one variable. The function has more than one independent variables. Suppose I will take it as z equal to, for example, f of x comma y. Here x and y are independent variables and z is dependent variables. I assume such a way that I will proceed. Okay, so I know how to take the derivative of ordinary derivative. So because there is only one variable, I can easily find what is the derivative. Now, in this case, how we can define? That is a beautiful. Okay. Now, I want to take the partial derivative over dou z by dou x at x naught comma y naught. So now I am going to see. So the x naught comma y naught is the point in domain. Domain of f of x comma y. Now what I am going to take? So it is automatically a surface. I will take y equal to y naught. It is a plane. This plane intersect with this surface. What will get it? I will get a some curve. So I denoted that curve is h of x. H of x equal to f of x comma y naught. Now you see that clearly it is a y naught is a some constant. But it's a fixed constant because I choose it that such a way that. Okay. Now it's only one variable. Now it is become so now h of x become a curve. I can easily find the derivative dh by dx, nothing but limit k tends to 0 h of x plus k minus h of ax divided by k. So what does mean h of x plus k? I know that limit k tends to 0. H of x plus k is nothing but f of x plus k comma y naught minus f of x comma y naught divided by k. So this is nothing but dou f by dou x. We are defined such a way. This is we consider as a derivative of partial derivative with respect to x. Suppose I want to take the partial derivative with respect to y. So similarly the x naught at x I want to find dou f by dou y at x naught comma y naught. Now you want to intersect with the plane is x equal to x naught. So it is given another function g of y such that f of x naught comma y then I take the derivative. Now we see two examples. So I define the function f of x comma y equal to x square plus 3xy plus y square. I want to find dou f by dou x at 1 comma 1 and dou f by dou y at 1 comma 1. How I can proceed? I fix. First step, I want to find dou f by dou x at 1 comma 1. This is nothing but I will take it as I fix y equal to 1. So it is a plane. I want to go intersect with this surface f of x comma y. So I get the function curve h of x such that x square plus 3x plus 1. Now I find that dou h by dou x is 2x plus 3. Now dou x by x value is also 1. So I want to dou x by dou x at 1 x equal to 1. This is nothing but I will get 5. This is my dou f by dou x at 1 comma 1. If again I want to take the derivative, partial derivative with respect to y, I will get the same answer. I will get it as 1. So we know that in ordinary derivative, in single variable calculus, we don't have the remark. Differentiability implies continuity, correct? But in multi-derivative, the partial derivative does not implies. Continuity. Why? So we see one example, that is a classical example. Now I define this function f of x comma y is 0 whenever x times y is not equal to 0, 1 xy equal to 0. So clearly this function is not continuous. Is not continuous at 0 comma 0. But what about dou f by dou x and dou f by dou y at 0 comma 0? What will get it? Please wait. Okay. So our aim is to find dou f by dou x at 0 comma 0. So what this implies, I fix is y equal to 0. It is a plane intersect with the surface f of x comma y, that is my h of x. H of x is always, I will get it as 1. Since y is 0, we fix it. So x times x is any number, it will always get the 1. So for all x belongs to real line R. So this implies dh by dx is, we get it as 0 for all x belongs to real line R. So this implies dh by dx at x equal to 0 also 0, This implies dou f by dou x at 0, 0 is 0. It exists and we got it, the value is dou f by dou x is 0. So now what about dou f by dou y at 0? At origin, dou f by dou y at 0, 0. This implies, now we fix the plane x equal to 0. Correct? Because the second, this part I will take it as correct. Now g of y equal to 1 for all y belongs to real line R. Then dg by dy is 0 for all y belongs to R. This implies dou g dg divided by dy at y equal to 0 also 0. This implies dou f by dou y at 0, 0 is 0. So you look, the given function is not all continuous at origin, but their partial derivative exists. So this is the I want to say mention that. So partial derivative exists does not implies continuous. That is the most important concept in partial derivative. Thank you for watching my video.